Hi, my name is. Today I'm going to talk about experiment Fourier transform infrared spectroscopy visible component analysis for vegetable oil examination. The part 1. You need to have the chemical suggest dichloromethan, 6 oil and 3 unknown oil, and you also need to instrument a thermonucleate X100 spectrometer. The part 2, you need to consider 6 to noise ratio and resolution. The first thing you need to the signal to noise ratio of spectrum is to increase the number of scans that instrument collect and average. To find signal to noise, the firstly you set the spectrometer to collect a percent transmitted spectrum at a resolution of 1. And then we need to collect a background scan with no sample in the pin part by selecting the collect sample in the spectrometer. After you collected the spectrum, you just set this spectrum in Excel. Step 4, you convert the spectrum to absorbance by using the equation A equal negative log T. And you continue the process further to collect the percent transmission for 4 scans, 16 scans, and 64 scans, and then you also convert this spectrum to absorbance. Step 6, to find bit-to-bit noise for 1 scan. The firstly you need to find the highest and the lowest point in the spectrum of 1 scan at the noise between 2000 and 2100, and then you just take the highest point minus the lowest point. And the same way you also find the bit-to-bit noise for 4 scans, 16 scans, and 64 scans. The lastly you need to consider 6 to noise ratio. You bit a scan to you for that part experiment. Basically, you choose the scan which has the highest signal to noise ratio. The second thing you need to consider when collecting a FTIR spectrum in the resolution of a scan. To find the spectral resolution, first you need to insert FTIR in the instrument, and then you clean the crystal with dichloromethan. Step 3, you repeat the step above, but at this time you set the spectrum with 16 scan average and collect the spectrum of canola oil at resolution of 0.548 and 16, and you say that this spectrum in Excel. Step 6, you need to extend the bit location in the 600 to 1500 range and 2800 to 3000 range in its resolution to find the best resolution. At part 3, you will collect the spectrum of 6 known oil and 3 unknown oil. To do this, you need to set the spectrum to 16 scan and 0.5 resolution, and then you clean FTIR redstone with dichloromethan, and then you put canola oil on FTIR redstone and hit collect on the computer 4 times to collect for absorbed spectrum of the canola oil, and then you read the step above for 5 remaining oil and 3 unknown oil to collect for spec of the 5 other oil and 3 unknown oil. And then you say the spectrum is Excel, and then for easy plotting the spectrum of oil MATLAB as you get the plot. Step 7, as you know, we got 4 spectrum of each oil for sample. For example, the spectrum of avocado oil on this slide, you need to choose 7, pick in the finger region and by zoom it on the first pixel. See the highest, and you can see 4 lines representing for each scan, and then you note down the highest point of each scan. Do the same way for 6 remaining bits, and then you transfer on way number into a single Excel spreadsheet. The result look like on the this line. The part 4, to identify unknown order put up on units, input the bit position data in the MATLAB after you perform PCR by using MATLAB function BCR. Step 3, and the common plot type code I show on the monitor. Step 4, you will plot BCR by type code at the common window. And step 5, in the same lot you add more the data unknown oil with unit symbol. You can tell which unknown oil will be belong to which known oil by trying to see which cluster of oil data point they go with. The part 5, the NMCH technique that can use instead of PCR and simpler to implement of spreadsheet process like Excel. The first you calculate the mean of each way number of kind of oil. The next calculate the absorbance difference between the unknown value and the mean weight number for each oil and each bit. After that, you sum the difference for each oil group of 7 bits. The unknown oil identified by on the smallest sum of different oil. And that's all. Thank you for listening, and I hope you enjoy my presentation.